class, we're going to show how to use the Gorgias spectrometer and the data that we can have from the pigment checker, the standard version, and the new pigment checker modern and contemporary art. We're going to test this system on this manuscript. This manuscript was dated at the auction as an 18th century manuscript, Indian Mughal, with Persian knights. We are going to see from what kind of information we can get from the analysis of the pigments. Analysis done with reflectance spectroscopy and using the standard Gorgias system. In particular, we are going to focus on the white of the, for example, of the horses. There is this white pigment on the hats also. And we are going to take this spectrum. Okay, so we go on the computer and we do the usual calibration of the system. Okay, there it is. Spectral reference, there it is. See how to make it. Okay, so we apply the probe over here as usual, and we look at the computer what's going on. So we want to take the sample, we turn off the light, we go on the white horse and we see a spectrum for this white, so we can stop the acquisition. Okay, there it is, and we can save this spectrum. So this is the white spot, and we save it on the desktop. So this white color was already analyzed using XRF, X-ray fluorescence spectroscopy. And we found that it has titanium. With reflectance spectroscopy, we can get a little bit more information. Indeed, titanium white can be made of two different kinds of crystals. These crystals, rutile and anatase, are made of the same atoms, so titanium and two atoms of oxygen. But they have a different shape, so the two crystals, anatase and rutile, are said to be polymorphs. The pigment checker have both these forms. The standard pigment checker, over here, titanium white, has the rutile form. On the other hand, the modern and contemporary pigment checker, among the white, over here, has anatase. So this is the other titanium white. Why is it important to be able to distinguish between these two kinds of titanium white? Because titanium white at the beginning was made using anatase. So from 1920s, from the 20s until 1940s roughly, titanium white, this pigment, was made of anatase. After the 1940s, basically there was a new recipe to make more cheap and affordable the production of rutile, and since rutile also had a better hiding power and was more chemically stable, it was preferred. So from 1940s, the production shift toward rutile. So basically, being able to distinguish among these two forms of titanium white allows us to actually perform a dating of the object. So basically, titanium white Anatase, the first form, was introduced in 1920s. So basically, from XRF we found titanium white, so definitely the object is not as old as it was supposed to be. Now, using reflectance spectroscopy, we can better define the time frame. So basically, if it's Anatase, it was made in the early 20th century, so between the 1920s and the 1940s. If it's made of rutile, it can be made yesterday, basically, because nowadays we just use rutile. Okay, so we want to compare these two spectra. So we remove the manuscript, since we already checked the spectra, and we are going to acquire the spectrum of rutile, that is on the pigment checker standard, the titanium white. We turn off the light, because there is too much. So we go here in titanium, then we go on the computer. Okay, I can stop this acquisition and save this spectrum. So I do save. So this will be rutile, and we save this one on the desktop. Then I pick up the other pigment checker. We go with the modern, and we analyze Anatase. There it is. Now we are actually measuring, and so this is Anatase. So I can stop, I can save this file. So name will be Anatase, and it goes on the desktop. Okay, at this point we can make a comparison. So we can use the usual software Spectrograph, which I recommend for the analysis of your data. This is a free software for institution, basically, so definitely it's worth to have a try. Okay, and we load the spectra that we just acquired. So we have rutile, reflectance, there it is. Then we have Anatase on the pigment checker, there it is. And then we have the white paint on the manuscript. Okay, so I make this legend a little bit bigger, so we can together figure out what's going on. Also change a little bit the color. Okay, Anatase, let's make it black. Okay, and bigger. There it is. Rutile. It's blue. Let's make it bigger so we can tell the difference. And then we have the white spot will be red. And let's make a little bit thicker. Okay, there it is. So basically, what we see here is that basically rutile and Anatase, this titanium white oxide, they both absorb the UV. But there is a big difference where this absorption starts. So for a rutile, the blue spectrum, so the common titanium white used nowadays, we see that the absorption is starting already will be 420 nanometer. On the other end, for Anatase, the absorption starts in the actual UV after 400 nanometer. And indeed, when we compare the spectrum of the white spot on the manuscript, we see that they overlap almost perfectly. So, indicating that this material this titanium oxide is made of anatase. And so basically we can tell that the object was made in the early decades of the 20th century. And also this data, this analysis was confirmed using Raman spectroscopy, the Elvira system, because anatase and rutile have actually different Raman spectra, so can also be distinguished by this technique. Though it's obvious that the advantage to use Gorgias reflectance spectroscopy is very important, because you see the acquisition is very fast, easy, lightweight, also to bring around the equipment. Raman spectroscopy is more powerful, but definitely the instrument is more delicate, require more time for the acquisition, but it's nice, as always, as I say, to complete your analysis with more tools to have more confirmation of the actual data. Thank you for listening.